young scientists. Today we're gonna do a series of experiments using the core of chemistry, acids and base. This is vinegar. It's made of acetic acid. This is quicklime. It's made up of calcium hydroxide. Now, how to differentiate an acid from a base? Well, there's something called a pH scale or potential of hydrogen scale, which has numbers. Okay, and if a substance has a pH scale lesser than the number 7, it is called an acid. If a substance have a number which is greater than 7 in the pH scale, that is known as a base. But what if the number of a particular substance in the pH scale is 7 itself? Well, those substances are said to be neutral. Examples for neutral things are water. It's not acidic, it's not basic. Now, I have poured the acid into this bowl and the base into this bowl. Now, have you learned about the story of Litmus paper? Well, I'll tell it to you one more. There's a plant named Litmus. We crush it and then we make a dye out of it and we make blue litmus paper. But as you know, there is the red litmus paper and there's the blue litmus paper. So where is this red coming from? Well, the thing, can you imagine how the red litmus paper comes? Well, if you said we dye it red, you're wrong. The thing is that you know how the reaction happens in litmus paper, right? When you add acid to the blue litmus paper, it becomes red, and when you add base to the red litmus paper, it becomes blue. Well, we add acid to the blue litmus paper and we dry it so that we can get the red litmus paper. Now we are going to use the same logic using our homemade indicators, turmeric indicators. How to make this? You take some turmeric in a bowl, you add water, and you take your paintbrush and you scoop up the turmeric, you paint it on a paper and make it dry and cut it into thin strips like these. That's how you get these indicators. Now, what change can be observed in this? If we did this, I need you to notice the color. It's this type of yellow. Understood? Now, we're gonna dip this in our acid. Come closer. Come on. I dipped it in acid. And as you can see, our paper became a bit more bright yellowish, right? And now what happens if I dip this in a base? It becomes blood red. See? Now, I only have these type of tamarind. What shall we do? We need another color just like the litmus. What do? Yes, we did this in the base and then we let it dry again, and after a lot of time after drying, we could dip this in acid again. After drying we get two different colors, one yellow and the other this. And if we dip the red one in acid, it becomes yellow. So let's do that now. Okay, alright, it was completely submerged and we made the whole thing red, as you can see. Now we're gonna put it for drying. Come on, right under the sunshine. Now we have two types of not litmus indicators. Now I'm gonna show you how this works. Come on. Look closely, okay? I'm about to dip this turmeric indicator into acid. See what happens. As you can see, when we dip this in acid, no changes can be observed. But if we dip this in base, come on, see what happens. Suddenly, this indicator becomes red. See? Now what about this red indicator? We're gonna dip this in base. No change at all. Now we're gonna dip this in acid. And as you can see, our red indicator, turmeric indicator, became yellow. The concepts of turmeric indicators were known to us, but then we did innovation.
Thanks for watching, we hope you learn. Science and humor are two main concerns. As we come to an end, we'll see you soon. Stay curious and keep laughing, that's our tune.